Hello everybody, and welcome to our video on section 16A about tangents and normals. And we're going to talk today about other equations, logarithmic, exponential, and trigonometric. So just recall from our previous lesson that when we have a function, the slope of the tangent is calculated at a particular point A. We can use the derivative to calculate the slope of the tangent. We can also find out an equation for the line called the normal, which goes through the same point of contact but is perpendicular to the tangent. The gradient of the normal to the curve is given by 1 over the derivative of the function evaluated at this particular value of a. Okay, and it's a negative reciprocal. So we're going to look at 3 examples here. First, we're going to find the tangent to the function e to the negative x at the point where x equals 1. So we need to find the equation. So our first step is to find the slope, also known as the slope of the tangent at x equals 1. That means we're going to take the derivative of e to the negative x, which is e to the negative x times the derivative of negative x, which is negative 1. And I'm going to evaluate it when x equals 1. So I'm going to plug in 1 here, and then you get negative e to the negative 1, or just negative 1 over e. I need to find the point of contact, which is what's the y value when x equals 1. So I'm going to plug in 1 to my original function, e to the negative x, this one here, not my derivative. And then f at 1 is going to give me 1 over e. So the point of contact is 1 and 1 over e. And then I'm going to write the equation using my point slope form. I'm going to plug in 1 over e for y1, 1 for x1, and negative 1 over e for my slope, my m value. I'm going to expand and collect like terms and simplify to get y equals negative 1 over ex times 2 over e. And I can leave it in that form. I don't need to use my calculator. For part B, we've got a logarithmic function this time. So same steps, we're going to find the slope of the tangent. So I'm going to take the derivative of 1 over, the derivative of ln of 2 minus x is 1 over 2 minus x times the derivative of the 2 minus x, which is negative 1. And then I'm going to evaluate that when x equals negative 1. So I'm going to plug in negative 1 for x over here. I'm going to get a slope of negative 1/3. I'm then going to find the point of contact by letting x equal negative 1 in my original function. That is ln 3, and I can just leave that as ln 3. And then I'm going to use my point slope form to write the equation of the line. So I'm going to plug in ln 3 for y1. I'm going to plug in negative 1 for x1 and negative 1/3 for the slope. I'm going to simplify and collect like terms. And in this case, I wrote it in standard form. Okay. You can write this in y equals mx plus b form as well. For our last example, I want to write the normal. So I'm going to take the derivative of ln of root x, which is 1 over root x times the derivative of root x. Okay, when I simplify that, I get 1 over 2 root x times root x, or just 1 over 2x. Now, I'm going to go to step 2. First, I'm going to plug in negative 1 for y here, and I'm going to solve for x. I'm going to do that by rewriting in exponential form. So I'm going to get e to the negative 2 equals x, or 1 over e squared equals x. Now I have the point of contact, so now I can calculate the value of the slope of the tangent. Okay, because we know where we found out what y was, not what x was, so I couldn't plug into here just yet. Now I know what the x value is, so I can plug it into here. I can solve for the slope of the tangent, which is e squared over 2. And then remember that the slope of the normal is the reciprocal, so I need to flip the fraction and make it the opposite sign. Okay, so it's the negative reciprocal of the slope of the tangent. Finally, I can rewrite this in point slope form, plugging in negative 1 for y1, 1 over e squared for x1, and negative 2 over e squared for the slope. Now I have an expression for the slope of the normal. For the equation of the line for the normal, and I can rewrite it in standard form as well. Thank you, and continue on to our next video.